In the previous video, we designed the Curvecade arcade system in Fusion 360. In this video, we'll be fabricating all the parts, assembly, programming, the electronics, and all that fun stuff to bring it to life. Stick around. Alright, so here we are, the Curvecade arcade. Lots of time has been spent in the design and development of this project, and the manufacturing and assembly is no different. There's lots of machines, techniques, and materials used to bring this idea to life. And we'll get to all that. We're going to cover all that in this video, but before that, if you're not subscribed to the channel, take a moment, click subscribe. It doesn't cost you anything, and it supports the channel. In addition to that, all the design files that went into this will be shared in the description below, as well as affiliate links to the products that I use to make this come to life. That said, put those all in the description. We've got a lot to cover today, so let's get started. Alright, when we last left off on the project, we had completed the design in Fusion 360. And we're doing this fly around. You can see all of the design elements that went into it. We've got edge-lit acrylic, we've got the wood sides, we've got a black acrylic inlay, and this formed acrylic. To get started, we need to do these side wood panels. And to do that, over on the Shapeoko, I first drill some pilot holes. This is how I'm going to mount it to my baseboard. Do that twice, obviously, because I've got two sides to mill. But I can't go all the way through, so I pull those off. We'll lay down some double-sided tape and 1/8" birch plywood. And this will raise it off my aluminum build plate so that I don't have to mill into that. Obviously, these were just pilot holes, and so I drill those all the way through the Baltic birch and prepare those for milling. Do both sides to finish off the operation. And I sand them down just to make sure that there are no burrs or anything that's going to affect the Z height. Using the pilot holes, I use some hex head cap head screws to mount them to the baseboard, and then I start milling out the profile of the side pieces. There's a couple pocket cuts. There's through holes for the side button as well as the speaker, and pilot holes for mounting it to the frame. Once the wood side is done, all the pockets are completed, we do a profile using a 2-flute ball end mill. Gives a nice clean finish. And then I remove this excess material, and the part's good to go. Next, we have the 1/4" black acrylic. Now, these are the side frames. It's thick, dense material, has a nice finish, although you won't see it. First, I draw all these pilot holes. First, I mill all these pilot holes, and then we start milling the channels for the LED lighting. In between those two channels for LED lighting is a speaker hole, and then you see the profile with the notch out of it. That large notch was for the monitor. I do 2 of those, and then I also mill these side inlays. These black acrylic inlays seat inside the wood frames, and you'll see that a little bit later. So we got the speaker grills, we got the side buttonhole, and then we cut the profile. Lastly, we cut some clear acrylic. That clear acrylic is the edge-lit acrylic, and so this gets sandwiched between the wood and the black acrylic. And you'll see there's some slots there, and that's where the LED lights shine in to edge light this whole piece of plastic. We also have the hole for the speaker and the button. Peeling off the protective layer. This is cast acrylic, of course. It's better for milling. It's a little bit harder. I use isopropyl alcohol to remove all of the adhesive that's from the milling operation. And then I mount that to the wood side. The reason why I do that is these need to be perfect. I don't want the edges to be different levels. And there's some tolerance that can cause it to be off a little bit. So using M3 screws and lock nuts, I screw them together, but there is a little overlap. I take that to the belt sander, sand that down. Sanding that down took some time, just got to be patient, don't want to over sand it, and just get that acrylic down flush with the wood. This acrylic that's being sanded will be paired with this, in this case it's the left side. We'll do the same thing for the right side as well. Once it's complete, I take it over and then use a foam sanding block, just kind of finish it off with a little finer grit down to 220. Testing the edge lid acrylic, I use the light on my cell phone just to see how diffused it is. It seems to work pretty well. So I disassemble this side and then keep those two parts separately. Next we take the frame, or the black acrylic, that's 6 millimeters, clean that up. First peel off the protective layer. None of these sides will be seen. This is just part of the skeleton framework that holds it all together. Using isopropyl alcohol, again, remove the adhesive that was built up on there from doing the through cut on the CNC. Get that all cleaned up and nice. There's a left and right, and they both have those LED pockets. Nice and clean and ready to go. Next we need to finish up the wood. So this is red oak, but it was very pale, and so to give it a little bit more life, I used a stain, and to prepare for that we did 220 and then Brillo pads, and then vacuumed them off, and then used a dust cloth as well, a tack cloth, to remove any remaining dust there. And then using this red oak stain, I just kind of rubbed it on there, and it gave it a lot better color than it originally had. This is a matter of preference. You could use any material. This material is bought from Lowe's, and it ended up being $30 for each of these strips. So $60 just in the side wood for this red oak. Crazy. In a future version, I plan on milling these sides out of aluminum, polishing it, and just doing a higher tech edition. Next, I use a satin finish lacquer and spray that on there to seal the wood and give it a nice finish. I think they turned out great. When they were dry, set them aside and move on. We've got the two sides, we've got the two black acrylic frames, we've got the clear acrylic, and then the black acrylic inlays. Next, we had to do these 3D printed parts. These are the parts that will hold the controls as well as mount the cross members. And these are all printed on a raft. Just kind of snap them off. They came off really nice. And these will be used with dowels to mount to the frames. So once that stuff was all cleaned up, peel that off its raft. You see we have a C profile there that clamps on those dowels. Originally, I had a closed profile, so this is the C and that's the closed. The problem was that the dowels had, from humidity, had swollen and they didn't fit in the closed profiles, so I had to reprint them with the open profiles. And I cut my dowels. Those were about 12 inches, 302 millimeters. So these are press fit into the ends. I press fit them in, and then I slide the components on, and then I press fit the opposite side on. So it was important for me to measure and keep at that 302 millimeter and get them just right. The ends also needed to align with each other, so I had to twist them in some cases. You'll see me doing that right here. So those pilot holes on those connectors needed to be aligned and the right length. So for each of these little sub-assemblies, for lack of a better word, we did one for the controls, we did one for the fan, and now we're doing the base mount. So this base mount was a bit of a puzzle the way I designed it. Originally I designed it as a single component, but to get better finishes on all of the surfaces, I broke it into 4 components, 5 components actually. We've got the 2 side rails, and then we've got a couple angled components in the middle. These are all held together on the dowels, obviously, and then we use some dowels as pins to align them all perfectly. See that? Then to make the wheel have some resistance, you can see I put the silicone tubing in those slots, which gives it some feedback and resistance so that it stays where you position it, which worked out pretty good. Again, I'm measuring these to 302. We got the length just right on these, and then we're ready to start assembling it. With the side frames in place, I began to screw these in using the M3 screws with lock nuts and a little torque wrench I got there. Has the torque settings, which was kind of nice, so that I could ensure that they were all tightened to the same amount, so as not to compress the 3D printed material too much. These frames are attached to those dowel end connectors. There's 3 of them total, 3 assemblies that comprise the whole frame. See, I'm doing this middle frame, putting the screws through there, torquing them down, measuring the outside dimensions, which with the acrylic on either side of that was 314 millimeters. In some cases had to adjust and compress them a little bit, and then finally putting the fan, and this is the final assembly of the skeleton basically, with the base on there. That base I didn't have to make, that actually came from the monitor. So the curved monitor had that base and it worked out perfect. I incorporated that into the design. Alright, with the frame in place, I had to create some forming bucks to bend the acrylic, and to do that I used 4 layers at 3/4 inch MDF. Laminated those all together, spreading the wood glue nice and evenly so as to get good coverage. Time consuming. These laminated boards would then sit overnight, dry and cure, because they would need to be milled the following day. Once this was all dried up, took it out of the clamps and then sawed it down to size on my bandsaw. I was sawing this down to the stock size in my design for these jigs and molds. Then I got the specific lengths of what I needed. We have a positive and negative mold component. Milled both of those on the Shapeoko. Here you can see we're doing the negative mold. Because of the depth on this, I had to use a 3-inch end mill, and I used all of it to get to the bottom of the mold. This is a negative mold, which would be used to clamp the acrylic when I'm bending it. You'll see how that's used in a few minutes. So this was pretty messy with the MDF and dusty process. And once it's complete, I had a really nice mold. So this was sanded down, and then I 3D printed some supports to strengthen those walls just to make sure that that laminate didn't break when I was applying pressure. And then we have a positive mold. This goes inside the frame and is used to support the acrylic as we're heating and bending it. The two kind of work together, and they have an 1/8 inch gap, which allows for the acrylic to be sandwiched in between those both. This is what I would use to form the acrylic. So don't have a lot of shop room, so I had to use my floor to mill that face, and then we laser cut the holes in it. And then you see how the forming buck was installed in the frame, and then I mount the face on that panel using a couple of the buttons. But before we can mount the face, we need to peel back that protective layer because we're going to be heating this, and we want to make sure that it doesn't burn the paper. Put a couple buttons in, and tightening those up sort of form it to that arc. And then I use a couple rubber bands to encourage it to be better arced, to make sure that I'm accounting for that space. Next, we prepare the molds that I'm going to use. And I use a heat gun, and this just takes time. It took about 5 minutes. You want to get that acrylic until it's about as pliable as a stick of gum. And the problem with this is I'm bending it 180 degrees, so I had to keep it all at the same temperature. And so it took some time. I had to keep moving back and forth and to get it all the right temperature. You see me testing it to see if it's ready to bend that far, what part needs more heat, and then I just work through that. You also see the tissue paper in the mold there. I've got that set up ready to use, and I was hoping that would prevent the wood from scratching it. And when it's at temperature, I throw it on there and clamp it down, let it sit for a few minutes, and then take it off. And that's all it took. It formed it perfectly, and once that's complete, then I would clamp it up, because there's a little air gap between the two. It's not exactly perfect, and make sure that the dimensions were correct. And then I would use some Star Bond medium acrylic glue, and that would pretty seal the deal, seal the acrylic face to the frame. Once that dried, I flipped around and do the same thing for the top. Again, just being patient with this acrylic, letting it tell me when it's ready to bend. When you see it start to sag, then I kind of test it and I move it around and make sure that I have an even disbursement of the heat, keeping it all the same temperature. I did have a little heat gun next to me, or temperature probe, that wasn't very helpful, because you really need to test the underside temperature of the acrylic, and it wasn't really conducive. So again, when it's at the right temperature, I use that forming mold and then clamp it down and let that cool down, usually for about 5 minutes, and then pull it off. Same thing on the top side. I pull out the forming buck, and then I insert the cross members, screw that down, and again I'm going to use that cross member to clamp it together to seal up that remaining little air gap, and then make sure that it's ready for glue, and then I'll get in there with the Star Bond and seal it up. Let that glue set up and dry, and then that acrylic face was good to go. Next, I had to remove the buttons, remove the cross member, because if you had noticed, I had a partial cross member in there so that I could mount a couple of those buttons. Now, to black out the bezel, I had to mask off the areas that I didn't want paint. I'm going to use black matte finish spray paint to black it out. We also do the same thing for the top. There's a top section of this that needs to be blacked out. So I'm protecting this acrylic from overspray as much as I can. Putting down that blue painter's mask. Cleaning with isopropyl alcohol, getting that surface ready to paint. Then spraying with a black matte finish spray paint. Did the same thing for the bezel on the monitor. You see it's all white plastic. Need to black that out, so masked it off and then sprayed off that bezel. Once it was dry, removed all that masking tape and checked the edges and checked for overspray and all that fun stuff. For the most part, it turned out pretty good. The finish was great. Some of the edges that met the tape were a little blurry. I probably could have burnished them a little bit better. We'll do that in the next one. Then I needed to remove all these cross members to get a final clean on that acrylic face. This is the last time I'd have the chance to do that before I put the monitor in. So I remove it, use a little glass cleaner, get all that overspray or any dust or dirt that was in there, clean up that edge. Then I slide in the monitor. Just slides right in through the side. There's a gap there on the side frame. And then using 1/4" foam sealant tape, I fill the gap between the monitor and the frame. It gives it some cushion, and it fills up any gaps that are there. Also kind of inadvertently holds the monitor in place. With the monitor in place, I reassemble the cross members, mounting the base stand mount there, then the fan mount, then I mount in the speakers. Speakers have 4 screws, and you can see that the speaker sound comes out of those holes. Got 4 on either side. Then I mount in the controls. You can also see that the joystick was already mounted in there, but I had removed the stick, so it didn't interfere with my countertop when I was assembling the rest of the components. Once that's done, I snap in the stick with a little C-clamp. Then I flip it around and start assembling the fan, mounting the fan in that cross member. That's good to go. The TV has this little D-pad, and for that I just use VHB tape mounted up in that cross member as well. It's a little D-pad that controls your brightness, color, volume, all that fun stuff. Next I mount the TV driver board. You see that on the back of the monitor now. And now I'm laying in the LED strips. Now if you can see here, there's a short strip and a long strip, and then they're all wired together with the speaker in between the two. Those white strips are the LED strips. They're RGBW, they're not individual addressable. Maybe in the next version I'll do that. Here's a quick view of the buttons. I threw them in there, confirming with the joystick and buttons what that final look would look like. And then here are the LED strips. You see they're interrupted with a speaker in the middle, and that's on both sides. The wires connect the 2 strips together around the speaker. Then you can see the M3 and the lock nuts there. Here's the D-pad. It's literally, just the D-pad. That's a cool design that they had on that monitor, and it worked out good for this. Before we get too far, electronic projects always start with good circuit designs, and for that I rely on Altium Designer. From simple to complex, if you haven't taken a chance to download a free copy and see what you're missing, I've put links in the description, and with Altium Designer, creating these complex projects is a piece of cake. Through your development, you'll be empowered to do your best work as you grow into its more advanced capabilities. The link in the description below will allow you a free trial version of the software so that you can check it out and see what enterprise class ECAD feels like. Now back to the overview. Next, it was time to do a lot of this electrical. Here we're wiring up all the buttons and joystick into the joystick controller that is a USB joystick controller that plugs right into the Raspberry Pi. Just had to plug in the ABXY, and then we've got left and right shoulder and trigger buttons, and then we've got a couple additional buttons on the side for the pinball games. We also have start and select buttons in the upper right and upper left corners there. Once it was done, used a bunch of zip ties to clean it up and route the wires. Then it was time to prepare the ends to all these speaker wires. You can see the Raspberry Pi mounted there to the left of the display driver board. Raspberry Pi, this is a 3A+, that is connecting directly to the HDMI input of the LCD driver board. We also use the audio out to control the volume of the speakers. In addition to the Pi and the LCD driver board, we've got an audio amplifier. That amp was a 5-volt. I didn't want to run it from the Raspberry Pi, so I put these buck boost, or this is actually a step down that goes from 15 volts to 5 volts. And that was sort of the awkward nature of this whole build, was that the monitor ran on 14 volts. And so I got a 14 volt 4 amp power supply, tore it apart, and you can see it right next to the stand mount that I put the internals of that AC 14 volt power supply, and then wired everything else up to it using step down power converters. We've also got a power connector there that went to from 14 to 12 volts for the fan. And you can see how once it was done, I cleaned it all up with a bunch of zip ties, and I got those wires all routed correctly. We also have an IEC connector for the mount. With all the wiring done, it was time to laser cut these rear panels. So these would cover up all of that and also be sandwiched between the clear acrylic and frame parts of the side rails. With the two side panels cut, I cut several tabs, and these tabs would be glued to the edges of the panels, and they would use to hook into the main body of the assembly. So taking those flat panels over there, these weren't heated to arch. They're just kind of hooked in one side and then screwed down, and they automatically bend to the shape of the arc, which worked out pretty good. So first I take off that protective side and then glue these tabs down. And then I put in some threaded inserts. This is where the panels will be screwed to the base. Using a wood block to kind of seat them and flush them. Next, I take the clear acrylic and the wood side, mount it up with a bunch of 25 millimeter M3 screws and lock nuts. And then I put some double-sided tape in that black acrylic inlay. Once the black acrylic inlay's in there, then I put that side button. Flip it over and do the same thing for this side. Put down the clear acrylic, put down the wood, screw it in with all the M3s and lock nuts, then put down some double-sided tape in that channel, and then drop in the black acrylic clear. And then finally put the button in there. With that, it's complete. Just time to clean up these edges and bring it all together. Pulling this off, you see we got the IEC connector and power switch, which connects directly to the power regulator inside there. Screwing that to the rear acrylic. And then screwing it down with a couple M6 screws. Put the base in there, flip it over, and then do the top part. So you can see the tabs there glued to the edge. Those are the tabs that hold the one side in, the other side gets screwed. So we put the tabs in, bend it to the arc, and then screw it in with the M6. With that, we've got our vents, we've got the fan there, clean it up with a little glass cleaner, and finish it off. Next, it was time to clean up this face. This is the first time I actually removed the face. So there was a lot of adhesive and dirt and dust that needed to be cleaned off on that. Using glass cleaner, getting in all those nooks and crannies to clean it all out. Next, I had some cut vinyl labels. You can see the Curvecade in the lower center, and then we put it on the start and select buttons, and then on each of the buttons, A, B, X, Y, left, right, trigger, and shoulder. And then hit that power switch. You can see the side LEDs come on. This little remote came with that. These aren't individually addressable. Maybe in the next version. This one just lets you, change some modes and, color changing lights. Here on the back, you see we got that logo there, the fans working. You got the vents there over all the electronics. And then you see the TV control there, also labeled. And this thing is almost good to go. We've got the IEC with the power connector there. Worked out really well. Looks really clean. We've got a custom emulation station Curvecade launch screen there. And then we're using a vertical theme for RetroPie and emulation station. For each of these games, I had to set up layouts, and those layouts would have the marquee at the top, and then define the region for the screen. I'm also using a shader that gives me the scan lines to give it that retro look and feel. Since this is a vertical arcade, I did it for about 250 games that all have their marquees up at the top, and it turned out really nice. Using the start button to drop coins and then select to start, or is it the other way around? Yeah, the select button to add coins and the start button to play one player. Here's Contra Classic game here that I suck at, but it's a lot of fun with these, having the bezel or the marquee change for every game. Here's Dodon Pachi. I'm not sure the correct pronunciation of that, but it is a great game. Lots of fun.
Okay, countdown begins. 3, 2, 1, go.
Pressing both buttons returns to the main menu. And select another game to play. Here's a little Donkey Kong Jr. action. Is it Junior? No. Classic Donkey Kong. Again, you can see here with the layout and the marquee up at top, specific to the game that you're playing, it's a really cool effect. I know other people have done this in other formats, but on the curved monitor it just works out really well. Side note, the shaders, when you run shaders with RetroPie or MAME or RetroArch, whichever you're using, they don't seem to apply to the marquee. So the marquee looks really crisp and clear, whereas the game screen actually has the shader with the scan lines, which is what you would want it to do. Here, to show off those LED lights, we've turned down the lights and we're just playing the game in the dark, basically. It really lights up the rear side of it, and it's a really cool effect. You can see how clear that marquee is there. Unfortunately, this was filmed on my iPhone with those wonderful lenses and lens flares picking up those bright lights. Here's another game, Time Pilot. In this mode, I just had those LEDs cycling colors, which look kind of cool. You can also turn down the brightness on those, or you can turn them off entirely if you don't like them. Here we are back looking at the Curvecade in daylight. You see those black acrylic inlays, the nice side buttons, the speaker slots. It really turned out nice. I was really happy with the results. It was a lot of work, and everything came together. Took a lot of notes for the next version, and we'll be sharing that shortly. Hopefully you enjoyed this deep dive look at the Curvecade arcade system, fabrication of all the parts, the assembly, and bringing it all to life. When you're tackling a complex project like this, obviously the more you invest in your design up front and the more knowledge and experience that you can apply into that design to anticipate problems and challenges that you may have when you start to assemble, the better off you'll be. In this case, things came out about 95% as planned, as designed. There were a few things and tweaks, modifications, widths, and registration points in the frame that I'll incorporate into future designs of this to improve the quality, improve the ease of assembly, and the ability to work on it after it's been created and assembled. So all in all, I'm happy with the design. Let me know what you think, how you'd improve it. One of the main drawbacks of this was that the design was originally made for a 900R curved monitor, which is a little steeper curve. This is an 1800R. I had already had this 1800R monitor disassembled, so the reason that I used that one instead of the 900R, which would have a nicer curve and aspect ratio for playing, is that I want to prove out the design here. Now I'll be updating the Fusion 360 for the 900R, and the next iteration will be a sharper curve. So that's going to look better, it's going to play better, and feel better. Aside from that, the dimensions on the monitor, the 900R is a 27-inch, and this is a 23-inch monitor. Put all the details in the description on all the parts and materials that I used here. They're all affiliate links. If you buy through them on Amazon and whatnot, then you can give me a little kickback, and the price is the same for you. I appreciate it. If this is your first time here, please hit the subscribe and ring that notification bell to keep you notified on future updates when I send out new videos. If you like this particular video, give it a thumbs up. In the meantime, be safe, have fun, and I'll see you next time.
Hey, if you like the video, please subscribe to the channel. It's how we're building the community. Also allow me to bring better content. Also check me out on these other social networks. There's lots of cool stuff there too.